Hello. In this video, I'm going to show you how to solve a system of equations using a table. You've probably already seen possibly solving equations using elimination and substitution. This is a way of organizing the information so that you can do kind of a combination of both of those strategies in a more efficient manner. Okay, so starting with a simple system of equations. We've got x plus y equals 5 and 2x plus 3y equals 13. And we're looking for a point or a value for x and y that satisfies both of the equations at the same time. You could graph it, you could use substitution, you could use elimination, or you can use the following process. So I'm going to set up a table, and I see here that I've got three different kinds of terms that are represented in these equations. I've got a term in x, I have a term that is expressed in y, and I have a constant term. So in my table, I'm going to be there will be three columns. The same is true for the second equation. It has an x term, a y term, and a constant term. So those same three columns. Because I have two equations, I'm going to have two rows. So two rows, three columns. So when I set it up, I'm going to take the coefficients of each of the variable terms, and those are going to be values in the columns. So I've got a term in x, a term in y, and I have a constant. I'm going to use k for constant, just because. And my equal sign, in the case of this first equation, is between the x's, y's, and that value of 5. So I'm going to put a vertical line there. Okay, so now I'm going to look at my coefficients. The coefficient of x is 1, coefficient of y is also 1, and my constant is 5. So what this bar, this vertical line, is representing is equality. So it says that 1x and 1y together add up to a total of 5. And then the second one would be translated as 2 in the x column, 3 in the y column, and then 13 is the total value of that. Okay, so in order to solve for one of the variables, to figure out what one of the x's is worth or one of the y's is worth, I'm going to have to find a way to eliminate one of them. And the way I can do that is using an addition or subtraction. So for example, if I were to take just straight off the equations as they are and add them to each other, that would give me some like terms. I would end up with 3x plus 4y equals 18. So that's another equation that I can write based on the two that I've been given. But consider if you did a subtraction instead. So I take the second equation and I subtract the first one from it. I'm going to end up with 2 minus 1, that's 1x, plus 2y equals 8. And that also is a true equation based on the two that I was given originally. So by a similar process, I'm able to eliminate one of the two variables. So I'm going to start by multiplying one of the rows by a value so that I end up with the same number in that column. So for example, here I've got 1x and 2x. If I double all of the values in that first equation, so multiply everything by 2, here, straight across the board, that's going to change my table. It'll change the first row so that it is 2 x's and 2 y's is 10. So I've just doubled everything there. It's a distribution. And now my second row has not changed. I've got 2, 3, and 13. There's my table. Now if I do that subtraction, if I take the first equation minus the second equation, or vice versa, the x variable, or the x terms, are gone because a number minus itself is 0. So let's do second row minus the first row. So I 2 minus 2, that's 0. 3 minus 2 is 1. And 13 minus 10 is 3. So in that step, what I've just figured out is that 1y is equal to 3. At that point, this is where you would use your substitution skills, and you could plug that in to figure out what the x is. Because originally, remember the first equation was x plus y is 5. So if x plus y is 5, and we've just figured out that y is 3, then that means that x has to be 2. So the solution, or the point that satisfies both of the original equations, is 2, 3. And you can plug that into both of them to verify that they do equal 5 and 13 when you do that. Okay, I'll show you another one. This one, we'll add in a negative, why not? So 3x minus 4y equals negative 15, and 5x plus y equals negative 2. Okay, so the setup is the same. In this case, I have 3 different terms represented in my equation, x, y, and constant. And once you get the hang of it, you don't have to bother writing the variables at the top anymore, but it's a good idea initially, just until you get the hang of it. Okay, so x's, y's, constant. 3, negative 4, negative 15. And then 5x plus 1y is negative 2. Remembering that if there's no constant that's been written, it's actually a 1. Y is equal to 1y. Okay, so what am I going to multiply these equations by? Nothing, if I subtract or add one equation to the other, nothing's going to eliminate. But I can see here already that negative 4 and 1, if I multiply the second equation by 4, that y term would eliminate when I add together. So I'm going to do that. I'm going to multiply the second equation by 4. And it's a distribution. I'm using the brackets just to indicate the connection to distributivity. So 4 times 5, so my first row has not changed. I'm going to leave that alone. 3 minus 4 and minus 15. My second row is now 4 times 5 is 20. 4 times 1 is 4. And 4 times negative 2 is negative 8. So there's my table at this point. And again, this is representing your equal sign. You could use a different symbol if you like, dotted or something like that, in order to remind yourself what that is. Okay, so if I add these two equations together, combining like terms, the x terms, I've got 20 and 3, so that's 23. This is an addition. Negative 4 plus 4 is 0, so I've just gotten rid of the y terms. Negative 15 plus negative 8 is negative 23. So right now this row tells me that 23x is negative 23. So that means that x has to be negative 1, dividing both sides by 23. So I figured out what the x is worth. And I can go back in and do a substitution to determine what the y is. I think that's going to be the simplest plan of attack for this one. So let's see, let's put it in here and the 5. So 5x plus y was negative 2. X is negative 1. That's negative 5 plus y is negative 2. Well, the only way that works is if y is equal to 3. So the solution for these two equations that were originally given, the point that satisfies both of them is -1, 3, and you could verify that using substitution in both and see that they do indeed create -15 and -2.